Have you ever typed a question into a search bar and been amazed at how it just gets you? You don't use perfect keywords, you just ask a normal question and it understands the meaning behind your words, and that's the magic of semantic search. But for the companies building these amazing systems, there is a hidden challenge. This magic can be incredibly expensive. And today, we are going to break down the secret weapon that makes it both smarter and cheaper. So, how does semantic search work? In a nutshell, it converts everything, your query, and all the documents or products it can search through, into complex mathematical representations called vectors. The search then becomes about finding the vectors that are closest to your query's vector. Imagine searching a giant online store with millions of products. When you search for durable hiking boots for cold weather, a basic semantic system has to compare your query's vector to millions of product vectors. That's a massive amount of computation. It's like asking a librarian to read every single book in the library just to find one paragraph. It's powerful, but it's slow and costs a fortune in computing power. So, how do we make it more efficient? We give the search system a brain. That's exactly what a knowledge graph is. It doesn't just store data, it stores the relationships between the data. Think about Netflix. A knowledge graph doesn't know about the movie Inception, it knows that Inception is a sci fi movie. It was directed by Christopher Nolan and it stars Leonardo DiCaprio. Leonardo DiCaprio also starred in The Revenant, which is a Western. These rich, structured connections are like a pre built web of understanding. And this is where we get our cost savings. Instead of brute force vector search across millions of items, a system with a knowledge graph does a smart two-step process. Let's go back to our e-commerce example, durable hiking boots for cold weather. Step one, the knowledge graph filter. The system first queries the graph, which is incredibly fast. It asks, show me all products that are a type of boot, have an attribute of hiking, and a feature of cold weather rated. Instantly, the graph narrows down millions of products to maybe a few hundred highly relevant ones. Step two is the focused semantic search. Now, and only now, does the system perform the expensive vector search, but only on that pre-filtered set of 100 boots. The result? You get a much more accurate answer. And the company saves enormous computation cost for that search. It's like the librarian already knows which three shelves to look into. So, by adding a knowledge graph, you are not replacing semantic search, you are supercharging it. You add a layer of structured contextual understanding that acts as a powerful cost saving filter. This combination gives you the best of both worlds, the nuanced understanding of semantic search and the rigid efficiency of a database. That's why, for any large scale, cost efficient retrieval system, a knowledge graph isn't just a nice to have, but essential. Thank you for watching. If you found this helpful, hit the like button and subscribe for more content on AI and data. Let me know in the comments section how you have seen knowledge graphs in action.